All right. Welcome back to PreCalculus. We're going to cover chapter 8.2 today. So I'm going to go through the PowerPoint and then we're going to do some practice questions from the book. Now I know this says circles and ellipses, but there's very little with circles involved here. In fact, the only part that I could find was in your book. There is some writing or some text or description of how circles are represented, and that's about it. So it's basically all ellipses. Okay. So transforming the unit circle, we're not doing any of that. So we're just doing geometry of ellipses, translations of ellipses, orbits, and then eccentricity, and the reflective property of an ellipse. All right. Now, why ellipses are the paths of planets and comets around the sun, or of moons around planets. We all rotate in an elliptical pattern. Okay, it's not perfectly circular, it is elliptical. So, now an ellipse is a set of all points in a plane whose distance from two fixed points in a plane have a constant sum. The fixed points are called the foci, plural of the focus of the ellipse. The line through the focus is the focal axis. The point on the focal axis midway between the foci is the center, and the points where the ellipse intersects the axis are the vertices of the ellipse. So, here it is. We have the focal axis, which is the line where the two focus points exist, and right in between them is the center. And then the point on the ellipse that is also on this focal axis, they're called the vertexes, or the vertices. We have center, focus, vertices. Now, it depends, again, if you notice, this kind of is more of a horizontal ellipse. Okay, it's flatter. If it was vertical, then you would see this function. So this function is more of a horizontal ellipse. This function is more of a vertical ellipse. Very similar to the parabola that we dealt with before. The difference is now we have fractions and we have the Pythagorean theorem. A squared is equal to b squared plus c squared. A little different than we're used to seeing, I think. So now this is the ellipse with the center on the origin. Just like with the parabola, we're going to have some of the questions going to be kind of easier because they're based around the origin. Okay. So the focal axis is the x-axis because this opens up horizontally, or sorry, is a flat, okay, stretching left and right. Here the focal axis is the y-axis because this stretches up and down. Again, just to give you an idea, let me draw this out. So here we have an ellipse. Wow. I don't know if I can. Nope, the answer is no, I cannot. So the center, we have the center at 0, 0. Ellipse. So it opens, stretches more horizontally. All right, and we're back. Sorry about that. So I wish I could draw this a little better. I guarantee you're going to see one that's better drawn than this. Hey, there they are. Okay, so let's back. Clear my horrible drawing off, and we'll talk about this. So the focal point, if you're given the equation, you're going to find the focal point being plus or minus c. Okay, so if you're given this equation, you can find c by basically doing c squared. So there it is. C squared is equal to a squared minus b, and then square rooting your solution. Square root. C is equal to a squared minus square root. Same thing over here. this is either way. This is how you're going to find C. Now, how do we know, given the equation, whether it opens vertically or opens horizontally? And it's really about which denominator is larger. Okay, because obviously A has to be the biggest denominator between this, because A is the sum of B and C. It has to be bigger than B. So if the larger denominator is under Y, then it opens up vertically. It opens up like this. If the larger denominator is under X, then it opens up horizontally. So this. So really have everything we need. Okay, we look at this. We know the vertices are basically the square roots of the denominators. So most of your denominators are gonna be nice and perfect squares. If not, it's not a big deal. And again, you have access to computers. You can graph a lot of these on Desmos. To be honest, if you want to graph these, graph one Desmos. It makes it really easy to do. So again, this would probably be good to have written down, just so you can kind of get visual information with this information, the visual side of it as well. So vertices at A, foci at C, and the semi-major axis. So the other vertices on the semi-minor axis will be at B. Basically, be this one, 0 plus or minus B. This one would be plus or minus B. Plus or minus B, 0, plus or minus. So find the vertices and the foci of this ellipse. Now what we're going to do is we need to have the function equal to 1. So what we're going to do first to divide everything by 36. 1. That's going to give you 1/4, or x squared over 4, plus y squared over 9. And since this has the larger denominator, it really should be y squared over 9 plus x squared over 4 equals 1. So we know that the graph is going to open vertically with focus points at, not focus points, vertices at 3. 1, 2, 3. And the semi-major vertices, 2. 1. There. Ish, okay. See why I never grade you on how well you draw your graph. Reason why. I understand. So we want to find the vertices and the foci. So we have the vertices. The vertices are at 0 plus or minus. Okay. Now the foci, it means we have to find C. And C is equal to square root squared minus B. So C is equal to square root 9 minus 4. This is A squared, and sorry, this is A squared. And this, so 9 minus 4 gives you square root of 5, plus or minus. So my foci are at 0 plus 5. Okay, super easy to do. And yes, I'm here you going, you're the math teacher, you know how to do this. Yeah, of course. So there they are. We have everything. Again, I like to write it in order. So there's your vertices, there's your... So yes, we did it correctly. So here, find the equation of the ellipse with foci of -2 and 2 whose minor axis. That means it gives us B is 2. Now minor axis is length of 2. Now that's the whole axis. Actually, B is just 1. You're going to divide that by 2 to get the length from the origin. And what I mean by that is draw this out. We draw this out. We have foci at 2, 1, 2, 1, 2. Those are the focal point, which means those are the values of C. C is equal to plus or minus 2. And the minor axis length is 2. So that means that this right here, 1, 1, should add up to 2. The whole length is 2. So 1, negative 1, B is equal to 1. Right? So we are going to find A by doing A squared is equal to B squared plus B squared. A squared is 1 plus 4, so squared is equal to 5. And the thing is, that's all we need, because the formula, being that it opens up horizontally, it opens up a little flat, is x squared over a squared plus y squared over b squared 1. So that's going to be x squared over 5 plus y squared, because over 1, you don't really put it, I mean, you can if you want, equals 1. They just want the equation. This. Again, we have a way of finding A, B, or C. They're going to give us 2 of them. They're going to give us a way to find A, a way to find B, or a way to find C. They're going to give us a way to find at least 2 of these, and then we can use the Pythagorean theorem to find the third. So if we need A, that's not what I want to do. We need A squared is equal to B squared. If we need B, B squared is A squared minus C squared. If we need C, C squared, A squared minus B squared. So we have a way of finding. We're going to have either B or C, A or C, or A or B. We're going to have 2 of them, or a way to find 2 of them. Here, we were given C, plus or minus 2. B equals plus or minus. And we were given a minor axis length is 2, which means B is plus or minus 1. So we have A and B. We have B and C. Find A. And that's what we're going to be given each time. Okay, we're going to have a way to. Terribly tricky, okay, but I like to phrase it. And again, it's going to get harder, because you're going to see what's happened next is, what if the origin is not the center? Now, all that means is you have to include an extra parentheses in your numerator. That's really it. And the location of the focal points and vertices are going to change, but again, it's really not too hard to find out how it's going to open. It's going to open up horizontally, or if it's going to open up vertically, because we're going to see what is changing. Okay, they're going to give us either the vertices or the foci, or they're going to give us something that lets me know that it opened, that the major semi-major axis is either vertical or horizontal, or the semi-minor axis is vertical or horizontal. So that gives us a way of knowing what kind of function we have. From the standard form of the equation for the ellipse, whose minor axis has endpoints of -4, 5, 4, and whose major axis has length of 8. So we know major axis length of 8. We have minor axis as it. So we have the major axis and the minor axis. Draw this out as best we can. So now the thing is, if we'll do some. We know -1, 4, and 5, 4. What is it remaining unchanged? The 4. So -1, 4, 5, 1, 4. Directly in between -1 and 5 is, so the center is at 4. So we already know is going to be x minus 2 squared and y minus 4. So what we have to do is find a and b. Now b is really easy because it's the endpoints. We can find the distance basically from the center to the endpoints of the minor axis. So that's from 2 to 5, which basically means b is 3. Minus 2, negative 3, plus or minus 3. Which means b squared is 9. We need that. Now, they give us the major axis has a length of 8, which remember, the whole length, okay, 1, 2, 4, or the whole length is half. Half the length gives you the length of A. So half of 8 is 4, so A is equal to plus or minus 4, and A squared is equal to have everything we need now. We know that it opens up vertically, so this should go first. Y minus 4 squared over 16 plus x minus 2. 1. So again, they gave us really an easy question to start out with. That's kind of nice. And so on this. So there we go. Again, I usually like to lead with the larger x. Put it in the correct order. It really doesn't matter, by the way. Really doesn't matter. But again, just because they have it set up that way here, that's the way I like to put it in the home. So it just makes it easier to grade. Okay. So let's see here. Okay, find centers, vertices, and foci of the ellipse. Now the center is easy. They give you the center right here. It's just change the sign, center. Center is -1, 1. Okay. Now the major axis is going to be in y, so that's where the vertices are going to be on. Okay, it's going to change the y value, and that means a is equal to plus or minus. I'm going to take the 1, and I'm going to have a vertice. So -1 remains unchanged. I'm going to take the 3. I'm going to add 3 to that, so 4, and I'm going to take away 3 from 2. So those are the vertices. And then the foci points, which means I need to find c. We know that c is equal to a squared minus squared and square root of that. So we kind of already know that 9 minus 4, which is square root of 5. It's a little harder to deal with square root of 5, so again, we're going to add or subtract square root of 1 plus or minus square root of 5 plus or minus. So the foci are -1 and 1 plus square root of 5, -1 minus 5. Right? Yeah. So center, -1, 1. Vertices, -1, 4, -1, -2. And the foci are -1 and 1 plus or minus square root of 5. I'm not going to deal with a lot of word problems in here just because we don't have a way to really go over them too much. But let's talk about eccentricity. Eccentricity of an ellipse. So if you're asked to find eccentricity, you're given eccentricity, what you're given is c over a, which is square root of a squared minus b over a. Which you can also say is just a squared minus b squared over a squared. Which you know what a, b, and c are. I think that's it for the PowerPoint because it just ends right there. So let's look at some of the practice questions. Go. To find the vertices, foci of the ellipse where these are given in, where the center is the the origin, so you're not asked to find the center because it's the origin. So, vertices and foci of the ellipse, I think we kind of just went over that, but I'll look at number 2. It's not too nice when they don't give you simple values, but I guess it's okay. I think it works out okay. The center is 0, 0. Right? And because y is first and has the larger denominator, that means it's going to change the vertices is going to change in y, and the foci points are going to be changed in y. So x is going to be the same. 0 something, and well, plus or minus something. We'll just minus something. In fact, it's going to be plus or minus the square root, basically a, right? So square root this, we get plus or minus 5. So plus or minus 5. Vertices are something. Foci points are the ones we got to work on because we have to do c. So again, c is equal to the square root of a squared minus b squared, which are your denominators. C is equal to plus or minus, so minus squared of 25 minus 21. C is equal to plus or minus 4 minus 2. There's how you find your vertices and your foci. Again, it's okay to have radicals. It's okay to have square roots. You can do plus or minus square roots. You don't have to simplify them or find the decimal value. Just leave it as a square root. You'll be fine. For number 5, make sure when you do number 5, first you got to get it equal to 1. And I'm sitting here pointing at the screen like you. All right, so for number 5 and 6, you have to divide by this, whatever. Divide everything by that first before you can do anything. So you know what order you're. All right. So this is match the ellipse. Right, it's kind of hard when looking at this because it's old. We'll see. Here we know these two, C and D, have centers around 0. We know C and D are equal to 7. Now we know that C has the major axis that is vertical, so Y should go first, which means that's 8. So 8 is C. Which means 7 is D. And here we have a center at -3, 3. That's going to be x plus 3, y minus 3. Is that 3? Oh, nope, that's 2. Sorry. -3, 2. So it's x plus 3, y minus 2. So 9 is A, which means 10 has to be B. So these are super easy to do just based on the center alone. That's sketch the graphic list by hand. Again, you could do it by hand. You can put it on Desmos. All these are sketching graph by hand. So these are the ones I'm going to give you. I'm probably going to just give you questions 1 through 5, and then down here 21 through 39. So let me write that down before I forget. I will forget this. 1 through 5, and then 21 through 39. Okay. So we're going to do some of these together. So let's look. I think we already did one just like number 22. Let me see if I can. Okay, sorry about the terrible photos. Hopefully you have your books. But I don't have a way to do this anymore on lens photo of it. Anyway, I'm just going to write 22, we had major axis. Major axis. 14 on the X. So that's nice. It tells us on. So it means it's going to open up horizontally, and it's going to have the X squared over A plus 1. So I know that. And these have to be on the x-axis. Because it's on the x-axis, we know the origin is the center. In fact, we kind of know the origin center all the way down through 0, 0, 0, 0, 0 on the y-axis. So from 31 down, you don't have the origin as the center anymore. So, minor axis is 10, so minor 10. I'm going to do this. That. Oh, wow. Me tapping on the board. All right. So we know this is the setup, but I'm going to write this back. We know it's going to be x squared over a b squared equals 1. Major axis 7, which means a is half of that, plus or minus 7. B is half of this, plus or minus 5. And really, we just square both of these. We get x squared over 49 plus y squared over 25 equals 1, and we are done. Again, any questions? I can actually ask questions. So, the next question. 24, foci. We're given the foci, which means we're given C, and the major axis length, which means we're given A, so we can find B pretty. And we know the center is 0, 0. So the foci is 0 plus or minus 3. Now, which means that this is going to open up vertically, so it's going to be y squared over x squared over b squared equals 1. Again, that's because the change is in y, so y first. And what was the major axis length is 10. Which means major 10, which means a is equal to 5, c is equal to 3, b is equal to a squared. Well, b squared, because we don't really need b. So b is equal to a squared minus c squared. So b is equal to 25 minus 9, so b is equal to 15. We have everything we need, b squared. So we have everything we need. A squared is 25. So we get y squared over 25 plus x squared over 15 is equal to 1. All right. Now, this is exactly like number 22. They just don't tell us major axis, minor axis, but that obviously is the major axis. It's bigger than that. So we know it's going to be x squared over plus y b squared 1, where this is a, this is b, so we already have everything. I don't even have to board x squared over 49 plus y equals 1. Done. I don't think this could get easier. Okay. Which means it'll get harder, right? Yeah. All right. Yeah, that was silly. Right, let's look at another one. Major axis is n.5, which again means x is first, because that's a change in x. So squared over 25. We know that's what it's going to be. Y squared. It says the minor axis is length 4, which again, we always divide that by 2. But if you square 2, what do you get? You get 4. These are really simple. And I'm not complaining. I'm glad they're simple. I hope you find them simple. Okay? But basically, all we have to do is find A and B. And these are giving us A and B. They're not even giving us C, unless they start giving us focus, which is C. Like here, that was the hardest one because we had to find B based upon C. Okay, so really these are nice. I'm going to skip down to one that doesn't have everything just right away. Let's look at number 30. We have the major axis at endpoints at -2, 3, and -2, 7, which again, because we know y is changing, and this is the major axis changing, that change is a length of 10. So we know the major axis is a length of 10, and that's on the change in y. And the minor axis is a length of 4. So major, your, minor, length of 4. So we know A is equal to 5, and plus or minus 5. B is equal to plus or minus 2. Now all we have to do is find the center. Now the center is halfway in between these 2 points. So what's the average of -3 and 7? If you add them together, you get 4. Divided by 2, you get 2. Center, 2. So we know y goes first. Y minus the y by the center, 2 squared, over a squared over 25, plus x minus a -2, so plus 2, over b squared, 4, equals 1. All right. Honestly, I think I'm going to stop here. And if you have questions, ask questions on Edmodo. But I think we covered everything we need to cover. Okay, we did question like this in the homework or in the PowerPoint. These honestly are really easy to do. So I think I'm going to just trust that you can solve the rest of these. So I already told you what the homework is. And hopefully you thought it was easy, just like I did. And we'll get it done pretty quickly. Now, here's the thing. This is the only assignment you're going to have this week. You have plenty of time to get it done. And I'm not going to really be available for questions. Okay? Because I'm recording right now on Thursday night, on the 9th. And my wife is due on 12th, Sunday. So we're kind of expecting next week to be a busy week where I may not have access to all your questions. See what I can do, but I'm going to be pretty busy after that. So here's also the thing. 8-3 is our last lesson. So we only have one more lesson. After that, what I'm going to do, I'm going to post a final review. Well, not really post a final review. I'll just basically post a take-home final and say this is open notes final. And just like the test, have a certain time limit to get it done. I'll probably give you a full week to get it done because it'll be pretty long. But what's going to happen is everyone is going to have a different final. All right, just so it kind of makes it to where you can't really help each other. You all have different questions anyway. Have to do the work. Somebody would have to do the work. Okay. So that's what I'm going to do. Is we're going to do that. but it's also going to be multiple choice because it's going to make things easier to grade. So that's what we're going to do. You're going to have a final that is pretty lengthy because it's going to cover the semester, but it's going to be multiple choice, so I can grade it. Back to you. What I'm going to do is I'm going to assign everyone a number, and that is, or a letter, and that will be the test that you take, either test, because there's only 12 of you guys. So I'll just assign everybody a test. Got your test, go take it, and then you submit it. One more lesson on hyperbolas. Similar, but I'm going to say it is a bit harder. Probably the hardest lesson, chapter 8. But hopefully you found these pretty easy. Anyway, have a good night. Stay safe. Would say I'm going to see you guys again, but I don't think I am because it's now closed for the end of May. I don't know what's going to happen. Stay safe.